Now we continue earlier lecture. Our today's topic is time independent Schrodinger's wave equation. Here we derive Schrodinger's time independent wave equation. This equation is also known as steady state wave equation. Since the wave function involved in this equation gives all information about the probabilistic behavior of the moving particle and the total probability of finding the particle in given region of space is constant and independent on time t. Therefore, that wave function represents the stationary state solution of the moving particle, and the potential involved in such a case is independent of time t. Here we derive firstly one-dimensional case. Hence, we use one-dimensional Schrodinger time-dependent wave equation. That equation we derived earlier, and it is IH cross dab of psi xt by dab t is equal to minus h cross square by 2m into dab square psi xt by dab x square plus v of xt psi of xt. This is taken as equation 1. Here we derive time independent equation. Therefore, psi of xt we separate into two independent terms. One depends only on position coordinate and other depends only on time. Therefore, we use separation of variable method, and psi term we separate the two terms just like psi of x into phi of t. Here we will use uppercase psi. That psi we choose the uppercase psi xt here, that must be equal to lowercase psi into phi of t. Also, v of xt is simply taken as a time independent term, v of x. Therefore, the equation 1 we write IH cross dab of psi xt by dab t. If we put the uppercase psi xt equal to psi of x phi of t. Here differentiation with respect to time t. Therefore, psi of x is kept constant and differentiations with respect to t means we write IH cross psi of x into dab phi of t by dab t. On the other side, minus h cross square by 2m into dab square psi xt by dab x square. Here psi of xt is taken as a lowercase psi of x into phi of t. Here differential with respect to x, therefore phi of t take outside and it is constant. Only differentiable term is dab square psi of x by dab x square plus v of x. Since potential we take in that equation is independent on time, it only depends on x, hence v of x right here into lowercase psi of x into phi of t. This equation we simplify by dividing psi of x phi of t on both sides of the equation, and we rearrange the equation. After dividing psi of x phi of t on both sides, we get the equation RH cross into 1 by phi of t, since psi of x to the numerator and denominator cancel, into dava phi of t by dava t equal to bracketed term minus h cross square by 2m into 1 upon psi of x, since phi of t numerator and denominator term cancel, into dava square psi of x by dava x square plus v of x, since psi of x phi of t cancel to the numerator and denominator. Here the equation 2 shows the RHS side of the equation only depends on t and LHS side only depends on x here. Therefore, each side, both t and x are independent. Therefore, each and every side must taken as a constant. That constant we choose E. Therefore, we write the two separate equations. IH cross 1 upon phi of t into dava phi of t by dava t equal to E. Equation 3 is time dependent term, and using that term we prove that the total probability or the probability density is independent on time and it is constant. That problem we solve at the end of this topic. Another equation is simply depends on x. Other side must be equal to some constant, that is E, minus h cross square by 2m into 1 upon psi of x into dava square psi of x by dava x square plus v of x equal to E. This equation we simplify in here. Equation 4 is time independent term. That equation simplifying by multiplying on both sides by psi of x. If we multiply psi of x on RHS as well as LHS, then what is the one side of the equation? Psi x cancel, which is numerator and denominator. Here v of x multiplied by psi of x. Other side is E psi of x. This equation is as a equation number A. Minus h cross square by 2m, this cancel. Dava square psi of x by dava x square plus v of x psi of x is equal to E psi of x. This is the equation A. Equation A, psi of x is taken outside and it becomes minus h cross square by 2m into dava square by dava x square plus v of x outside bracket psi of x is equal to E psi of x. Here the bracketed term represent sum of kinetic energy plus potential energy. How the first term is kinetic energy? Since minus h cross square into dava square by dava x square is a result of x momentum operator square. Since p of x is equal to minus I h cross dava of dava x, we take its square, we get minus h cross square by 2m into dava square by dava x square. Since px square is minus I square, means minus I h cross square dava square by dava x square. Therefore, the first term is the kinetic energy term and second is v of x. Kinetic energy plus potential energy is the total energy and the total energy term is equivalent to another operator in the quantum mechanics. That operator is known as Hamiltonian operator. Hence, Hamiltonian operator, or it is taken as a total energy operator. Hence, in terms of Hamiltonian operator, the equation A becomes H psi of x is equal to E psi of x. Or we simplify equation A by multiplying minus 2m by h cross square on both sides. Therefore, minus h cross square by 2m into 2m by h cross square cancel, minus minus plus. Simply the term is dava square by dava x square. Second term is minus twice m into v of x by h cross square. Outside we write psi of x is equal to minus twice me by h cross square psi of x. We rearrange the term and rewrite another form of the equation A. My dava square psi of x by dava x square, since this is simply term, plus 2m by h cross square. This minus term we take on that side. 2m by h cross square e minus v of x into 2m by h cross square into psi of x. This 2m by h cross square is outside, and inside bracket term, remaining term is e minus v of x psi of x equal to 0. Equation A or A dash both represent one-dimensional time independent wave equation, or it is steady state wave equation in one dimension. Now we extend one dimensional into three-dimensional case here. How we extend the three dimension? We use earlier equation A. In that equation, psi of dava square psi of x by dava x square, dava square by dava x square, that is only here the one dimension term. We extend into the three dimension, then this term is replaced by dava square by dava x square plus dava square by dava y square plus dava square by dava z square. Here v of x is here in one dimension. If we extend three dimension, here we write v of r. This potential is only depends on space coordinate x, y, z into psi of r. X replaced to r equal to e psi of r. Therefore, first term in that equation, dava square by dava x square replaced by del square, and psi of x replaced by psi of r. Equation rewrite after putting the value of Laplacian operator. Del square is equal to dava square by dava square plus dava square by dava y square plus dava square by dava z square. That term is a del square and it is a Laplacian operator. This our equation becomes minus h cross square by 2m into this term replaced by del square, or dava square by dava x square plus dava square by dava y square plus dava square by dava z square. Psi of x replaced by psi of r plus v of x replaced by v of r. Again psi of x to psi of r equal to e psi of x equal to e psi of r. Or equation directly in del square minus h cross square by 2m del square psi of r plus v of r psi of r, this is as it is, equal to e psi of r. This equation also write in Hamiltonian operator. This minus h cross square by 2m del square plus v of r. Outside we write psi of r. The first term represent kinetic energy term. Second term potential energy, sum of kinetic energy and potential energy in the 3 dimensions. Again, it is a 3-dimensional Hamiltonian operator into psi of r is equal to E psi of r. Equation as like earlier, we are again simplifying by multiplying minus 2m by h cross square on both sides of the equation, and we rearrange the term. It becomes del square psi of r plus 2m by h cross square E minus v of r outside bracket psi of r equal to 0. That equation combined with the minus h cross square by 2m del square psi of r plus v of r psi of r equal to E psi of r, or h psi of r equal to E psi of r, or del square psi of r plus 2m by h cross square E minus v of r psi of r equal to 0 is one 3-dimensional time independent wave equation, or it is steady state wave equation. Now we prove that. To prove that the total probability is independent of time, or it is constant. Hence we use the time dependent term that we separate. In this case, equation is IH cross into 1 upon phi of t into delta phi of t by delta t equal to E. We simplify LHS and RHS by delta t take on the other side. RH cross, it gets denominator on the other side, and equation becomes 1 upon phi of t into d phi of t, this is one side, equal to E divided by IH cross into dt. Here we integrate on both sides. Once we integrate this equation, 1 upon phi of t into d phi of t equal to integration E by IH cross into dt. Constant term we take outside on the other side, E by IH cross take outside of the integration into integration dt is t plus constant of the integration. We get the equation integration 1 upon phi of t into d phi of t, or delta phi of t we keep as it is, meaning is same, equal to integration E by IH cross dt. It simplify 1 upon phi of t into d phi of t, means this is a log term, log to the base E phi of t, equal to result of that integration equal to E by IH cross take outside since it is constant. Integration with respect to t, therefore we write t plus constant of integration c. To find the constant of integration at time t equal to 0, c becomes equal to 0. Since t is 0, here t is 0, c becomes equal to 0. Since value of c is 0, equation becomes log E phi of t equal to E by IH cross t, and that 1 by IH cross simplify by multiplying to the numerator and denominator by I. Therefore, denominator is I square is minus 1, numerator is I by H cross minus of I by H cross E into t. Now we cancel log term on both sides, and it becomes phi of t is equal to exponential minus I by H cross E into t. Here, in terms of frequency, we write exponential term. That exponential term becomes phi of t is equal to exponential minus I omega t. This is the one of the equation we write. That equation represent, it is the time dependent term which varies harmonically with frequency omega. And using that Hedge term, we simplify equation A once it depends on time and it changes harmonically with frequency omega. As psi of xt, uppercase psi of xt is equal to lowercase psi of x into phi of t. Separate x and t since both are independent. And here we put the value of phi t. This is the equation small a, psi of x into exponential minus I omega t. Take complex conjugate on both sides. Psi uppercase psi star xt star is equal to psi star x into exponential minus I omega star. I is the imaginary term. If we take its complex conjugate, minus I becomes I or I becomes minus I. Therefore, exponential term is exponential I omega t. Therefore, we take the product to find the probability density. Psi of xt into psi of xt star equal to psi of xt is psi of x into exponential minus I omega t into psi star into exponential I omega t. Here exponential minus I omega t and exponential I omega t cancel since the numerator power addition we take in that exponential term, and simply the one side becomes psi of x into psi of x star, and this psi x star is constant and it is independent on time t, and therefore we prove that the probability density of finding the particle in given region of the space is always independent on time and it is constant, and that is the proof for Schrodinger time independent wave equation. Here we complete that article, Schrodinger time independent wave equation in 1 and 3 dimension. Earlier we discussed Schrodinger time dependent wave equation in 1 and 3 dimension with and without external force. Here we complete the total Schrodinger wave equations. Thank you.